In this video we will learn about logical operators, and the logical operators perform a logical operation on two or more numbers, expressions or arrays to see if the combination is true or false. As you can see, there are three logical operations: and, or, and not, and you need to be familiar with their symbols, like the and the bar for or, and the tilde for not. And these are the when each of them is true. So and is true only if both ends, the left and the right expression or numbers, are true. So if the expression in the left is true and the expression on the right is true, it's the only time it's going to be true. Any times else, let's say if this is false and false, then it's false. False and true is false. True and false is false. Or is the opposite. So it evaluates false only if both ends or both sides of the or are false. So false or false makes false. Everything other cases will give true. So if there is a true or false, that means it's true. True or true is true. Then false or true is true. Not, it's only one side, so it evaluates true if the what's next to it is false, which is like negative. Negative makes positive, so not false becomes true. So that whatever number or expression following the not should be false for the not to be true. If we are talking about numbers, the only way to be false if the number is 0. Any other non-zero number will give you a true. If we are talking about expressions, then if the expression is it's either true or false, like what we'll see in the following examples. In the first example, we said about and is the only time and is true if both the left and the right side of the and are true. So we said 3 is not a 0, so this is a true. 7 is not a 0, so this is true. So true and true makes a true, which is evaluates as 1. And if you look at the second example, we said or is false only if both sides of the or are false. So 5 is true, the 0 is false, so we have true or false, so that evaluates as true, which is 1. So it has to be false and or false for it to be 0, so that's not the case here. Okay, let's look at more examples in MATLAB. So let's look at the first example here. So if we assign a variable x equal 5, and let's look at the and here. So we use expressions here. So the two expressions from the first expression, x is larger than 2, so 5 is larger than 2, so that's true. If you look at the other expression, 5 is smaller than 8, which is true. So true and true, that should be a true. So when we run this, we should get a 1. And you can see we got a logical 1. The second example, x is 5, so let's see here, 5 is larger than 2, so that's a true statement or expression. If you look at the other expression, 5 is larger than 8, so this is a false. So true or false, because we have or, so this is still true. So let's run it and see what we get here. And we got a true. Okay, in the next example we have again still 5 equal x equal 5. So the expression here, 5 smaller than 2, so this is false. And if we put not in front of false, so not not false becomes true, so that should evaluate as true. And you can see when we run it we get a 1, which means true. So in the next example we could also run the logical operators on arrays. So let's say if we have an array of 5 individuals, the age of 45 to 11, and we like to classify them based on the age if they are teenagers. So we define the teenager to be between the age of 13 and 19. So that's mainly the expression here. So age should be larger than or equal to 13, and age should be more or than or equal 19. And we remember from the previous when we looked at the slide, and on the only time and is true if both sides of the and are true. So let's look at the first one. So 45. So 45 is larger than or equal to 13. So that's true, but 45 is not less than 19. So that makes it true and false. So that should be false. So we should get an array with the first element 0. And we can evaluate the other ones. So let's run it and see what do we get here. Okay, so we get 0, 0, 1, 1, 0. So we said for the first one, we already discussed that. If you look at the second one, it will be the same. So let's look at 15. So 15 is larger than or equal to 13, so that's true, and 15 is less than or equal to 19. So true and true is true, so this is why we got the 1 here. If you look at the 13, then it meets both conditions, so it will evaluate as true. And like what we did before, we could simply find the number of teenagers from the array here just by using the sum by adding the ones, because it only adds if there is 1. If there is 0, it will not affect the results. So in this case, it will give us there are 2 teenagers in the list we have here. And to summarize, we could use the logical operators with numbers, variables, arrays, and just remember that with AND, the only time it's true if both ends of the ANDs are true. So true and true give you a true. Every other scenario will give you a false. Or the only time it's false if both sides of the OR are false. So false or false give you false. Everything else will give you a true, and not only have one side, and whatever following the notch should be false for the expression to be true, which is kind of not false, change it to true. And also, as I said, you need to remember the symbols: the bar for or, the and for and the tilde for not.